Imagine the following scenario. You are building an e-commerce application. The user has a cart. They can add items to this cart, change the quantity, remove items, proceed to checkout. You might want to model this as events that you will then publish to Kafka. If you choose to do this, you will have quite a few options on the table. The first and the biggest choice is whether you actually want to put these different event types in a single topic, or do you want to keep them in separate topics. If you choose separate topics, this will be pretty simple. It will also allow your consumers to subscribe only to the events they are interested in, which can lead to significant performance gains and cost benefits if you have consumers that are interested only in specific record types. But if your consumers need to process the events in the exact order they happened, choosing this approach means forcing them to deal with consumer-side reordering, event time semantics, watermarks, and so on. This is a lot of complexity that can be avoided. You can also choose to publish these different event types to the same topic. It is a bit more complicated to set up and manage, but it does save your consumers from the complexities of reordering parallel streams. You simply put all of the events that happened to your shopping cart on the same partition, and what the consumer sees is a continuous stream. It is way easier to build consumers in this scenario. In this video, I'll talk about putting multiple different event types in a single Kafka topic, what choices you will have, what are the consequences of these choices, and what compatibility issues you need to watch out for. You'll also see a demo of two examples. We'll be building a fat union schema with Avro, and we'll be using schema references in Protobuf. The demo you will see on Avon, today's sponsor. They have recently launched a free Kafka tier that allows you to provision a small two-broker cluster with a Schema Registry and a REST proxy included. The free tier doesn't require a credit card and it doesn't have an expiration period. And as usual, all code is available on GitHub. Since this is an advanced topic, I recorded a separate video where I provision the free Kafka tier cluster using Terraform and record it step by step. Here we'll just do the advanced part, but this is a shared repository. So if we want to put many different event types in a single Kafka topic, how do we do that? Let's start with the most naive method. One way to do it is to have a single schema that has multiple optional fields, and each of these optional fields is one certain event type. But modeling it like this comes with certain problems. The most obvious one is that it doesn't scale really well. The more event types you have, the larger schema you have, and this can be problematic. Another issue is what happens if you see an event where two of these optional fields are present. What does it mean? This schema doesn't clearly communicate intent, so it introduces cognitive overhead for developers that will be using your code. So this option, I don't consider this the best option in any scenario. But what if instead of multiple optional fields of a fixed type, we could have a single field of a flexible type, where we provide the list of possible types ourselves in the schema. The name of this pattern will differ from source to source. I'm calling it a fat schema or a union schema. And what this means is that you'll still have a single schema where you define all of these possible event types, but this just will be one field. Or in Avro, not even a field, a top-level union type. And it's better. You still have this large schema, you still have the complexity related to maintaining the schema of unknown size, but it is more clearly communicating the intent and it's easier to understand. And if you want to implement this, you can still keep your schemas in separate files and just merge them during build. It makes it way easier to work with. And this is what I'm showing in the first example. We have a single Avro schema assigned to our topic with a top-level union type, and the possible event types are also defined within this schema. In my demo, I'm keeping the Avro type definitions as separate files, and I'm constructing the union schema in Terraform. You can do it like this, but in production setups, you'll probably prefer to merge the different event types during your CI/CD build, and then use this ready schema in Terraform, because then your repository will be your source of truth. Okay, now that everything's ready, let's deploy it to Avon Cloud. And this is how the resulting schema will look like, a union of two record types. When you want to configure a consumer, it's a bit more complicated than consuming a single record type, but almost all downstream systems should be able to handle it. So now that our schema is deployed to our environment, we can publish and consume these messages. Keep in mind that since we're using Karapace REST proxy, the deserialization happens in Karapace. If you're using the Kafka protocol, deserialization will happen in your consumer. If you are enjoying the video, remember to like and subscribe for more data streaming content. And on 18th of February, I'm launching the first edition of my schema management with GitOps workshop. It's a one-day remote hands-on workshop where you will learn everything you need to know about this topic, and we still have seats open. Okay, we have our union schema, but this approach has downsides. If you want to define many event types and if the definitions are large, the union schema can get really unwieldy. It also doesn't allow you to independently evolve your subjects. Some Kafka clients have an interesting configuration property, 𝗦𝗫𝗫𝗫𝗫𝗫𝗫𝗫𝗫. It controls the process of looking up subjects in Kafka clients. In Schema Registry, the primary entity that you manage is a subject. This is where you assign your schema. When you want to evolve the schema, you deploy a new schema version to your subject. During this process, Schema Registry validates whether the desired schema is compatible with the current schema according to the configured schema compatibility rules. The default subject name strategy is TopicNameStrategy. Your subject is your topic name. But this is not the only one. There are two other subject name strategies that you can use, RecordNameStrategy and Topic RecordNameStrategy, which means that your subject is either a record or a topic plus record. So you might think, and I did in the past, that maybe we can use these alternative strategies directly in our Kafka clients. If you choose a different subject name strategy for your topic than topic name strategy, it will be pretty easy to send messages to this topic, but it will be really hard to deserialize them. Why? Because the tools that read the messages don't have an explicit list of possible types they can deserialize. They don't have a schema that can just use and evaluate. They would need to understand what a schema registry is and how to do it. And even in Java, which has really good support for schema registry, this is not trivial to make. But many tools will just not be able to deserialize your messages. Because of this, it's not a good idea to use these strategies in your topics directly. A very promising feature present in many schema registries is schema references. The idea is simple. We register our subjects independently and then keep references to them in the main schema. This allows us to evolve them independently, solving the problems of coupling between different event types and maintaining a huge union schema. There is an issue though, ecosystem maturity. Not all schema registries support schema references, and for clients to be able to use them, they need to understand what they mean as well. If they don't, they will not know how to resolve these references. Some schema registries support server-side dereferencing. What it means is that instead of returning a schema with references, the references are resolved server-side and the client sees exactly what you would see if you had this one big union schema. But to enable this behavior, the clients need to send certain arguments, so this means client-side coupling. As far as I know, no schema registry today allows you to configure this behavior as the default, so all of them rely on clients compatible with them. I believe that once we are able to configure schema dereferencing in the server configuration, combined with schema references, this will be the best general solution for the problem of many different event types in a single topic, because it will allow us to manage our subjects independently, while also presenting familiar behavior even to older Kafka clients. But we are just not there yet. There is another interesting problem that you'll need to understand if you want to use schema references in GitOps. If you want to use references to a different subject in your schema, you need to provide the version ID of this subject. This is a problem because this ID is assigned when you actually deploy it. So you cannot just create one pull request with two clear schemas. You need to either add a variable and then navigate the connection, for example, which is quite often used in Terraform state. Or if you are using Apicurio, you can avoid this problem altogether because Apicurio allows you to provide the schema version yourself instead of generating it during deployment. In the second example, I'll show the implementation of schema references in Protobuf on Avon. Karapace has support for schema references, however Terraform Avon provider doesn't, so I've introduced a workaround using MasterCard REST API provider. This is not ideal, but it can be helpful for the demo because it explicitly shows you what's going on, that you need to deploy the subjects first and only then you can deploy the schema with references. Apart from simply deploying the schemas, there is some glue code in there that solves the problem I've described earlier, that connects the versions of the event types you are registering as subject with your top-level schema that stores these references. Using a dedicated GitOps tool like 𝗦𝗂𝗯𝗷𝗲𝗰 would be cleaner, but also it would complicate the demo. Once I apply the setup and check the event console for results, you can see my subjects registered as separate resources and the top-level union schema that has references to the subject. Subject versions are passed in Terraform, and then the top-level union schema is successfully registered. I can then publish and consume these events with my Python scripts using Karapace REST API. So if you want to keep multiple different event types in a single Kafka topic, I recommend these two solutions. The first one is the Fed union schema, where you maintain the schemas for your events in separate files, but then merge them during the build deployment process. Using schema references can be a great solution in certain environments with more integrated technology stacks. For example, in a modern technology company built completely on Confluent platform, it will be way less risky to use these features that don't have such broad support. I also hope that soon we'll be able to configure server-side schema dereferencing in Apicurio and Karapace. And once we have that, the clients will see the exact same schema as they would if you use the Fed union schema pattern, but with the added benefit of being able to manage your subjects independently. This is why I've dedicated so much time in this video to schema references. I think it's a great solution, but we have a problem right now, the poor ecosystem maturity, and this will inevitably improve over time. So that's all for now. Thanks a lot for watching. I hope you enjoyed the video and it was helpful. Remember to like and subscribe for more data streaming content, and I'll see you in the next one.